Hello everyone. So today is day 33 of our DSA challenge, right? So continuing the sheet, we are going to solve the question called reverse a linked list in groups of size k, right? And the question is given, see, it's a hard type question, right? And you can see that the type of companies it has been asked in Amazon, Microsoft, Capital One, Facebook, Google, Bloomberg, and so on, right? So it's a hard type question, and I think this is the first question in 30 in all the days till now that we are doing the hard question. I guess this is the first question, right? So yeah, the question says that given the head of a linked list, reverse the nodes of the list at a time and return the modified list. K is a positive integer and is less than or equal to the length of the linked list if the number of nodes is not a sorry, multiple of k, then left out nodes in the end should remain as it is. So this is important, okay? You may not alter the values in the list node, only node themselves may be changed. Okay. So like, all right. I know there were a few jargons in here. Let me tell you in a very, in a layman language what it says. So one, four, five, six, seven, eight, 9, and we can take a 10 as well, okay? And this is pointing to null, okay? K, let's say, is given to us as 3. That means we have to take a group of 3, right? So this is first group, this is the second group, this is the third group. But since 10 is, see, there is only one element, right? And here, if you notice the line, if the number of nodes is not a multiple of k, then left out nodes in the end should remain as it is. That means we will not reverse this thing. As that is, this will remain as it is. This part will remain as is, right? Okay. So let's understand what we need to do, right? So see, this question is hard because there is a lot of implementation, okay? You have to understand each and every step of the algorithm. Obviously, I am sure that most of the people won't be able to do it in a single go, or probably, they won't exactly know how to solve this question. And that is why you can see that in in these many companies, this has been asked only. See, the frequency is low and everything. So without wasting time, let's see what we need to do, right? So the first thing that is given to us is nothing but 1, 2, 3, and 4, 4, 5, and blah blah blah, right? I have written till here because I need to explain to you something, right? So for now, let's just assume these are the elements, right? These are the elements. This is the head given to us, okay? And we obviously take a temp. Cool. Okay. So the first thing that I will do is take this, right? That means this should look like 3, 2, 1, and so on, right? Cool. So this is our what do you call this is our sub output, right? This is our sub output. Okay. So let's try to do this. What will be our kth node, right? Kth node will be obviously plus 3, temp plus 3. That means here is my kth node, right? Obviously, right? Okay, cool. Now we have obviously done this question called reversal linked list, right? And see, although linked list is almost in, see, it has the same work as arrays, right? It is used to store values. And although the implementation is a lot different, but the work is almost the same thing. But in some areas, this thing obviously does not mean that it will be done exactly like arrays only. Anything can be done in arrays only. So my point is, you cannot just reverse this part and then move to this part and then reverse this part. You will have to reverse individual linked lists until and unless this thing is pointing to null. You cannot obviously reverse just a middle part of it. So, okay, this thing is for sure in my mind that I can only reverse sub-linked list, as in sorry, I cannot reverse sub-linked list. I'll have to reverse an individual linked list. Okay. So that means I will have to make it to point to null, right? I will have to make it to point to null. Okay. See, this is the next element. And obviously, the whole this is a sub part of the algorithm, but we'll have to move to 4, 5, 6, and then to 7, 8, 9, right? So obviously I'll have to keep a track of 4 as well. So for now, I'll say that you are nothing but next, and then I pointed to null, and then I pointed to null. Now this is what my linked list is looking like. Okay, 1, 2, 3, right? 1, 2, 3. Here is my head, here is my temp, here is my k node, right? I can obviously reverse it, reverse, reverse, right? And assuming that this has been reversed, because we already know what the algorithm for reversing look like. So this will now be our reverse linked list, correct? Correct. My head is here, my temp is also going to be here, and my k node will be here, correct? I am not playing around with temp and k, right? I will see when I'll write the code, you will understand what I'm trying to say right now. But see, my temp is here only, and head is here. My k is also here, right? Okay. So if my temp is equal to if my temp is equal to head, that means I know that hey, this is the first subpart. This is the first subpart that I'll have to reverse. That means I will bring my head from here to the k node, correct? Because this is how my subpart should look like. This is how my subpart should look like, and head is nothing but 3 only. If you see 3, I know that this is not a longer list, but this 1 to 3 was our sub part, right? And 3 is now the head. So this is that I know that if my temp is equals to head, that means my this is the first thing that I'm trying to reverse, and so my head will be at k node, at k. Okay, great. So this is that I've done. This is I've already done. Now next thing that comes is that I have next node. I have next node, right? Remember? So now I will say that hey, 4, 5, 6, and blah blah blah. Let's just take 7 and 8 also, and blah blah blah. Right? Okay. So my next is here. I can bring my temp to here as well. So here is my temp. Cool. Here is my temp. And obviously my k will be here. K will be at 6. This is for sure. This is for sure. Because when I'll find the kth node, then 6 will be my kth node. That means this is my second sub output that I'll have to do. This is my second part of the second group, basically, right? Okay, cool. Again, this becomes my next, and what I'll do is I will now make it to point to null, right? Because if you remember, I can only perform reversing on an individual linked list and not the sub part of it. Cool. Okay. So what does my list look like? 4, 5, 6, where this is my temp and this is my k node, correct? And this is pointing to null. Cool. Reversing, reverse. What does this look like? It looks like 6, 5, 4, where this is k and this is my temp This is pointing to null. Correct? Correct. Okay. Okay. If you remember one thing, I wanted to join this to this linked list, right? This linked list is right now pointing to null. But what does my entire thing look like? 3, 2, 1, 6, blah, blah, blah. So if right now 1 is pointing to null, I wanted to point to 6, right? Okay. So here comes the thing that you'll have to remember. Right now, my before moving on to the next group, my wherever my temp was, I need to store it somewhere. I need to store it somewhere. So what I'll do is I will mark this as previous node so that I have its reference, right, for the later part. And now I will say that, hey, my priv dot next should be equal to temp. That means I will remove this. That means my current thing, it looks like, sorry, 3, 2, 1, 6, 5, 4. Although this is pointing to null and we have another list called 7, 8, 9, 10, pointing to null again. So this is kind of list 1. This is kind of list 2, where my K is at this point, my temporary is at this point, right? My next is at this point, and my priv node was at this point. This is my priv node, this is my K, this is my next node, this is my kth node, this is my temporary. Cool. This is pointing to null. Now what? What is the next subgroup? This is the next subgroup, right? This is the next subgroup. But before that, if you remember, I want to first of all save hits reference. Okay, so let's save it. So this becomes my priv. Priv from here moves to this. Okay, cool. My new node, my next node is now pointing to kth node. The k will be 9, and uh where can I take any other? Yeah, I can take this. This is my temporary. My temp will come to the next, next node, that is 7. Next node from here moves to 10, and my kth node will be 9, right? Okay. And now this will point to null. So that means my third group is now this. Similarly, same thing. Reversing, this looks like 9, 8, 7, pointing to null. This is my temporary. This is my kth node. Cool. Same thing. Now my priv node, sorry, where is my priv node? Yeah, this is my priv node. Priv node should point to 9. That is my kth node. So 3, 2, 1, 6, 5, 4. This is my priv node. 4 is my priv node. Should point to my kth node, that is 9, 8, 7, and my temp node, my temporary node, right? This my temp should point to next, should point to next, point to next, should point to next, correct? And now my last group will look like this, but 10 is only one element, but we need 3 elements to form a group. So that means this should be joined to all the remaining elements, all the remaining nodes. So if it had been 10, 11 pointing to null, if it had been 10, 11, 12, then it could obviously form a group, right? But if it was 10 and 11, also this this is two elements and two is obviously lesser than three. That means this also will not form a group. So this will now, this thing should point to the remaining elements, that is the this group, right? So if you carefully observe, if you carefully observe, uh, 3, 2, 1, 6, 5, 4, 9, 8, 7, and 10. Isn't this my output? Right? This is my output, right? Okay. Let's try to write the pseudocode for it. Right? Try to write the pseudocode for it. Okay. I will say that, hey, I will have temp is equals to head, correct? Okay. I will have a priv node. I will have next node. Cool. Or maybe not next here. I can just say priv node for now. Okay, no problem. So while my temp is not equal to null, right? I will first get the kth node. So my k node is nothing but get k node that takes temporary as head and k as second argument. This is a function which will return me either null or it will return me the kth node. Why it will return me either null or the kth node? Obviously, the kth node will be returned if there are at least three elements. If there are if there are elements equal to k, right? Equal to k. If there is a group that exists, but if there is a situation where this is like this situation, right? That means it has to return me null. That is how I will know that, hey, I do not have this much k elements left in your linked list. So that is why I am returning you a null. So that means I will have to later on in my algorithm, I will have to join it to the remaining elements. Join this the second last group to my remaining elements, right? Okay. So assuming we now have k, we now have kth loop. Okay. Sorry, kth node. I will check that if my k node, k node is equal to null, right? If it is equal to null, then what I have to do? What I'll have to do? I will have to join it to, I will, what I'll do is, I will say that, hey, temporary, go and join the, you go and join the next, you go and join the next node. So temp dot next, you go and join the next node, right? You go and join the next node, correct? Okay. Else, or else kya? Why should we even write else? We already know that, hey, and I will say that, hey, you please break out of the loop, break out of the loop. I don't want you to run more because I know the other elements are not a part of my are not part of my algorithm anymore. Cool. So we have broken down. We have broken out of the loop. Cool. Okay. Now what is the next thing that I'll have to do? I will have to have next node. I will have to have next node, right? So just give me a minute. Yeah, I think there's a mistake. We are not joining the temporary to the next node. We are saying, sorry, we are saying, sorry, this is a mistake, right? I will say that, hey, priv node, priv node, sorry, dot next, you become equal to temporary. You become equal to temporary. Okay. Okay. So this is done. This is done. Cool. Now, my next node is now equal to temp.next, correct? This is obviously short because I have to have the reference of the next node for my other things. And I will say that, hey, t.next, please be equal to null because I have to have separate individual linked lists, correct? Okay, cool. Now I will say that, hey, reverse passing t, and this will give me, you know, 3, 2, 1 pointing to null. This will give me this thing. Cool. Okay. I will have to check something. I will have to check something. What is that? If my temporary is equal to head, that means this is my first group. This is my first group. If this is true, if this is true, then I will say that, hey, my head is equal to what is my head equal to? My k node. My k node, right? My kth node. Else, right? Uh, I will say that, hey, priv node, you become equal to what? You become equal to temp, obviously, because my previous node, I was already saving it for this purpose only. You become equal to temp, and temp, you now become equal to my next node. Correct? Okay. And my while loop will obviously break out of here, and I will return simply the head. Okay. Here is one thing that is missing, okay, in this line. What is that line? If priv node exists, if it is not equal to null, if priv node is not equal to null, then only do this. Then only do this, right? Because I am asking, I am saying that priv node, you become equal to temp at this position, at this position. But what if if, take an example, if this is, and k is equal to 3, what should be my answer? You tell me what should be my answer. If I don't have any previous node, how will I even, make it point to point it to temp, right? That is why having a null check is important. Okay. So I think this, we have done all the things. We have done all the things. But let's check. Let's check. Okay. Number one. Number one. Check. Find the kth node. Right? We have done that. Check if k node is equal to null. If yes, then what do we have to do? If this is null, then we have, what we have to do? Let's check here. What did we do? We said that, hey, priv node, you become equal to temp and then break out of the loop, right? You break out of the loop. Priv node dot next is equals to temp and then break, right? If yes, and we have, and that, and the fourth, we don't need to write else condition because we already know that the whole algorithm is based upon an else only, right? So this is done. This is done. But before that, before reversing anything, I need to save next node, which will be nothing but temp.next, correct? Uh, k node will be, oh, sorry, not temp.next, k node.next, right? Because k will be my one node before the next node, right? 5. I will say that, hey, k node dot next, you please become equal to null because I want to treat you as a individual linked list as an individual linked list, right? Then reverse the individual linked list. Seventh, what is the next step? What is the next step? I will say that, hey, check if the temp is equal to head. That means if it is the first group or not. If yes, it means it is the first group, right? If it is the first group, then what you have to do? What you have to do? You have to say that, hey, head, you please become equal to my k node because I know that you will be my first element, right? Else, else I will say that, hey, priv node, please, I have to save you. I already did. I already have saved you. But hey, priv node, you please become equal to temp. You please become equal to temp. And at the end, I will say that, hey, temp, you please become equal to my next node. You please become equal to my next node. And we'll end the loop. So these are our criteria that we need to finish upon. Find the kth node, then check if it is null. If yes, then priv node is now equal to the temp. If and then we'll have to save the next node. We'll point next k node to null. K dot will point to null because we have to treat it as an individual list. Then we'll reverse that individual list. We'll check if it is the first group or not. Then if we have checked, if it is the first group, then we'll say that, hey, head, you become equal to k node. Else, we'll say that priv node, please, I'll have to save you somewhere. I'll have to have your reference for my further use. And then this becomes my temp. And at the end, I will say that, hey, temp, you become now equal to the next node. I have already written the code. Let's see the code, right? Let's see the code. Reverse k group. I will save temporary as head and I'll have a previous node. Getting the kth node, right? We'll figure about the function later on. Then I'll check if k node is null. That means k node is now equal to null. That means there isn't any kth node. That means there is no element that is left to be a part of a group, right? Or cannot be a group. We don't have in the other group. If previous node exists, priv node dot next you become equal to temp and we'll break out the loop, right? Else, what we'll do is we'll say that, hey, list a next node, I'll have to save you somewhere. And because I'll have to treat you as an individual list, I'll reverse the linked list. And if my temporary is equal to head, that means it's the first group. That means it is the first group. This means it is not the first group, right? If it is the first group, head you should be equal to k node. Else, previous node dot next is equals to k node, and priv node will be equal to temp. Temp is equals to next dot node, next node, and we'll return the head. Let's see what our k node function looks like. Very easy. See, I will simply say that, hey, temp is not equal to null, k greater than 0, k minus minus. Temp is equal to temp dot next. I'll just simply move the temp. I'll simply move the head, right? And well, return the temp code. Reversing, we already know how it looks, right? We'll have a current element, we'll have a previous element, we'll have a next element, and this is the. Let's try to run this code. Accepted, submit. Great, accepted. Let's discuss the time complexity, right? Let's discuss the time complexity of it. Where is this? Yeah. I am finding k elements for this group. That will be constant. I am finding kth node for this. I am finding kth node for this. Almost finding kth node for this as well, right? If this is taking, let's just say O of 3, O of k, right? O of k This is taking O of k. This is taking O of k. This also while might also take O of k, right? K into 4 should almost be equal to my n, right? K into m, where m is equals to number of groups of size k, right, is equal to n. That means I am taking I'm taking almost O of n to find the find kth node, correct? Plus O of I am individually what I'm doing is I am individually reversing this group, reversing this group, reversing this group. Obviously not reversing this group, but at least I'll though I'm not passing it, but at least I'm passing these three groups for sure, passing these groups for sure. Again, O of k plus O of k plus O of k. That means reversing this group, this group, this group. This group takes constant time. This group takes constant time. This group takes constant time, right? But in together they will take an O of n time, right? So another O of n time for reversing k groups, right? Which is equal to O of 2n, correct? And space complexity, it will be constant because we are not taking any extra space, correct? So can we mark this question as done? We can, right? We can. And what we can do is I can copy all these things. I can copy all these things and paste it in the notes. Marks this as saved, right? And this has done. See, this question is genuinely difficult. That is why it is marked as hard, right? That is why it is marked as hard. It is meant to be difficult. But if you just go through the code, if you just go through this code, right? This code, then you will have to obviously dry run. You will have to dry run a lot of uh, what do you call linked lists, right? Linked list you'll have to dry run on. Then what you'll have to do is just read these 10 points, 10, 11 points are and mark and make it as a checklist. Am I doing this? Yes, I'm doing this. Then if I'm doing this and dot, dot, last element should temp should be equal to next node, right? This is important. These things are very important. So that then when you mark all these as done, and you'll obviously be able to form your own algorithm or your code, right? So yeah, with this, I'll just take your leave. Check if a palindrome is check if a linked list is palindrome. Very easy question. You don't have to worry about it. Just worry about this question, right? In this list, you just have to worry about this question. Yeah. Thank you so much, guys. I'll see you tomorrow. Bye bye.